Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to solve problem 1.5 from the chapter Some Basic Concepts of Chemistry. This is related to the concept limiting reagent. So students, if you don't know what is limiting reagent and how to identify limiting reagent in the given question, I have already made a video on this. So a super trick is there to find the limiting reagent. So you can find that video in the playlist and you can watch the video. So here you can see this question. The solution for this question is very big. So here some of the students were asking it is difficult to understand this problem. So watch this video. I'll teach you in a very simplest way. I'll teach you a trick. Okay, using that trick you will be easily solving this question. So at the end of the video you will say that, oh, this problem is so easy. I was finding it very difficult before, but after watching this video I'm finding this question very easy. So that is how you are going to feel. So let us start the video now. So first read the question what is given. 50 kg of nitrogen and 10 kg of hydrogen gas are mixed to produce ammonia gas. Calculate the amount of ammonia gas formed. Identify the limiting reagent in the production of ammonia in this situation. So here two things are asked. One is find the amount of ammonia formed. Second is identify the limiting reagent. So first let us write the question. So what you have to find is, first you have to find limiting reagent. LR is called as limiting reagent, question mark. Second, you have to find the amount of ammonia formed, ammonia gas formed. So these are the two questions you have to find. So now let us start the first part, that is finding the limiting reagent. So to find the limiting reagent, so I'll teach you a trick. Use that trick to find out. It will be very simple for you. So first what you have to do is, first trick. So trick number 1 is write the balanced chemical equation. So you will write nitrogen plus 3 times hydrogen giving 2 times ammonia. So this is the first trick. So always write the balanced chemical equation. So second trick is you have to write the number of moles, small n. So this is nothing but number of moles. But in the question number of moles is not given. Instead of that mass is given. So for nitrogen mass is given as 50 kg. And for hydrogen, the mass is given as 10 kg. We should convert this into the number of moles. So how to convert it? We are going to use the formula. The formula you are going to use is number of moles is equal to mass divided by molar mass. This is the formula. So now for nitrogen first we will find the number of moles. So n, number of moles, is equal to mass is given as 50 kg. So 50 convert into grams. So 10 to the power of 3 grams divided by molar mass. For n2 the molar mass will be 28. So 28 grams. So now divide this. When you divide this you will be getting 1.786 into 10 to the power of 3. So this is equal to, now shift the point here. So here 1 decimal if you shift here, when you want to shift 1 decimal here, you have to subtract minus 1 in the power. So it will become 3 minus 1 will be 2. So it will be 17.86 into 10 to the power of 2. So this is the number of moles of nitrogen. So here I'll write 17.86 into 10 to the power of 2 for nitrogen. Next I have to find for hydrogen. So next we will find for hydrogen. So for hydrogen, number of moles, N is equal to mass. Mass is 10 kg. So 10 into 10 to the power of 3 grams divided by. So for hydrogen, the molar mass will be equal to 2.016 grams. So divide this, you will be getting 4.96 into 10 to the power of 3. So this is the number of moles. So again write here for hydrogen, the number of moles is 4.96 into 10 to the power of 3. So we found for nitrogen, this is the number of moles. For hydrogen, this is the number of moles. So in the question it is given, initially we are taking these many moles of nitrogen and hydrogen. So what is limiting reagent is whichever is taken in smaller quantity, that is called as limiting reagent. So in this we have to find which is taken in smaller quantity. So for that what we are going to do is, so for 1 mole of N2, 3 moles of hydrogen is required. So according to balanced chemical equation, for 1 mole, so you can see here for 1 mole 3 mole of hydrogen is required, but in the question it is given 17.86 into 10 to the power of 2 moles of nitrogen. Then how many moles of hydrogen is required? So take that as x. So now cross multiply this, cross multiply like this. So when you cross multiply, you will be getting x is equal to 17.86 into 10 to the power of 2 into 3 divided by 1. So if you divide this, you will be getting 5.36 into 10 to the power of 3 as the answer. This many moles. So here the meaning, what is the meaning of this is, for 17.86 into 10 to the power of 2 moles of nitrogen, this many moles of hydrogen is required. 5.36 into 10 to the power of 3 moles of hydrogen is required. But in the question what is given is, they have taken only 4.96. So instead of taking 5.36, they have taken 4.96. So this is taken in smaller quantity. So whichever is taken in smaller quantity, that will be taken as limiting reagent. So now therefore this will be the limiting reagent, that is hydrogen. Because it is taken in smaller quantity, this will be called as limiting reagent. So here you will write the first part, hydrogen is the limiting reagent. Is this clear? So this is how we find the limiting reagent. So second part is find the amount of ammonia formed. So for that again you have to write the balanced chemical equation. So let us write nitrogen plus 3 times hydrogen forming ammonia, NH3 gas. So now here what you should do is again follow the same method, that is write the number of moles. N is the number of moles. So here we have to write for the limiting reagent. So here we have 2 reactants, nitrogen and hydrogen. So here always take the limiting reagent, the number of moles for the limiting reagent. So for hydrogen, what is the number of moles we got? See here, we got 4.96 into 10 to the power of 3 moles of hydrogen we got. So take for hydrogen, the number of moles is 4.96 into 10 to the power of 3. So this is the number of moles. For ammonia, what is the number of moles? It is not given, we have to find. So take this as x. In the next step, write the stoichiometric coefficient. So stoichiometric coefficient meaning is the number which is present with the element. So with the hydrogen, the number present is 3. And with ammonia, the number present is 2. So 2 will be the stoichiometric coefficient, and here 3 will be the stoichiometric coefficient. So here you will write 3 and here you will write 2. Next step is divide the number of moles by stoichiometric coefficient. So you will write here 4.96 into 10 to the power of 3 divided by 3 is equal to x divided by 2. So cross multiply this. So when you cross multiply, you will be getting x is equal to, so 4.96 into 10 to the power of 3 into 2 divided by 3. So simplify this. So when you simplify this, you will be getting 3.30 into 10 to the power of 3 moles of ammonia. Moles of ammonia you will get. So we are getting in terms of moles. So number of moles of ammonia formed is 3.30 into 10 to the power of 3. But in the question, what is asked is amount is asked. Amount means you should find mass. So now we have to convert this into mass. So formula again will be the same. That is, you have to take number of moles is equal to mass divided by molar mass. So now number of moles of ammonia, just now we got it as 3.30 into 10 to the power of 3. So 3.30 into 10 to the power of 3 is equal to mass we have to find divided by molar mass of ammonia. So what is the molar mass of ammonia? So NH3 molar mass will be for nitrogen, it is 14 plus hydrogen, 1 hydrogen is 1, 3 hydrogen means it is 3. So here 14 plus 3. So 14 plus 3 will be 17. So it will be 17. So now M will be equal to 3.30 into 10 to the power of 3 into 17. So multiply this, you will be getting the answer as 56.1 into 10 to the power of 3 grams of ammonia is formed. So in the question, this is converted into kg. So convert this into kg. So this is equal to 56.1 kg of ammonia is formed. This is the answer. So the final answer is 56.1 kg of ammonia. So see in the question here, 56.1 kg of ammonia is formed. So this is how we are going to follow. So follow this trick. So easily you can simplify and get the answer. So students, did you like the video? Did you find this solving this problem very simple? So if you like the video, do share this video with your friends and also subscribe our channel. I'll meet you in the next video, students. All the very best.